Maria was speaking about the Spark code, the RDD API just a few minutes ago. So from there, what I am going to go to is SparkSQL and Dataframe API. So before we start, how many of you have used Pandas data frames, R data frames, and SQL, Hive? Okay, great. So I'm going to speak about Dataframe API and the SparkSQL API. So before we start, let's just have an idea about what data frames and SparkSQL is. So okay, as we established, so in brief, data frame API. So a data frame is a collection of data that is organized with named columns, and so the data frame API is very similar to R and Pandas data frame programming model. So the thing about the data frame, Spark data frame API, is that instead of constraining yourself to small data in Pandas or R, you can use the same programming pattern to handle petabyte, terabyte scale data. And if you think about SparkSQL, it has the similar idea. So it's the main part of the SparkSQL engine is the Catalyst SQL engine that Spark has been working on for a while. So what Catalyst pretty much does is it takes SQL like commands, and first thing it optimizes these queries and then scales it up to be used in big data. So SparkSQL also provides Hive context, which lets you do a bit like Hive-like commands. So before we dive into the API, the code examples, let's just find out what are the key differences between the RDDs and the data frames. So in a nutshell, data frames have schema and RDDs don't. So what does that mean? So what that pretty much means is that when you take a data frame, Spark is aware of the underlying schema that the data that the data frame carries. What that means is Spark knows, okay, is this particular field an integer, is it nullable, so on and so forth. So what that means is that by having that extra information, whereas an RDD can optimize on the data transformation pipeline, Spark can use this extra information about the data type and etc. to further optimize the computation process. So for example, if we know that the age column, for instance, is an integer, Spark can figure out based on that what range of values that this data would carry, and what would be the best compression algorithm, what would be the best way to store and transport this data. So using this, data frames allow you to optimize further on how the data is being transformed. So on a logical sense, RDDs focus on how to obtain the required data, whereas data frames are more focused on what data do we need. So this aligns greatly with one of the core design principles of Apache Spark, which is we should be able to do simple tasks easily, but complex tasks should be possible. So data frames enable you to do simple tasks easily, whereas the RDDs let you do complex tasks possibly. So before we move to that, so then the other thing is RDDs can be turned into data frames, and data frames can be turned into RDDs. So with that, let's move to the tutorial. So in the last 40 minutes, Maria was going through all the capabilities, most of the capabilities of RDD API, like mapping and so on and so forth. So Spark Data Frame API also sort of enables similar functionality. So through this tutorial, what I'm going to explain is how it is being enabled and like why it is simple and efficient to use Dataframe's API to do simple things in when you are handling big data. So, first we are just going to have a look at the data. This is this first command is nothing, it has nothing to do with data frames. I am just using the RDD API to read the text file. So, as Maria explained earlier, this data has these JSON objects which are in string form in text files. So, now we are moving into the Dataframe API, where because data frames have underlying schema, there are two ways that you can load data into a data frame. The simpler way is that you load the data and you let Spark figure out the schema of the data. So, that is called I will identify that as inferring the schema from the data. And the other way to do it is we can, as a the developer can explicitly define what schema should be assigned to a particular data set. So, let us start by first we need so in order to run RDD you need the Spark context. Similarly, to deal with SQL and Dataframe API, you need the SQL context. So, we will start by instantiating the SQL context, and the first example what we are doing is we are reading the same JSON file that we loaded earlier. Instead of defining anything, we are just letting Spark figure out what the schema is. So, we load that data, and the main difference you see here is it is no more a text, it is not a Python dictionary or anything. So, in data frames records are stored as rows, and these rows have column names and values. And here what we can see is based on the data, this Spark has figured out okay, async is more likely to be a string, helpful is a tuple of integers, overall is a float, and so on and so forth. So, the thing about our Dataframe API is that it has a schema, and there is this very elegant function which is very useful when you try to figure out debug your data frames. You can visualize how the schema looks like. So, when you look at this, you can see that Spark has identified that async is more likely to be a string, and helpful is an array of integer, array of long, and overall is a double, so on and so forth. So, then there is the second approach where you can manually specify the schema of the data. So, how that works is, so Spark SQL types module give you a range of different data types. So, we can use these data types to define okay, this is the structure that I want the data that I am reading to have. So, in this example you can see what I am doing is I am defining a schema for the same data, whereas I am explicitly defining okay, the reviewer ID should be a string and async should be a string, and etc. So, once I do that, you can see that there is a struct type is like a structure. So, this structure defines what the underlying data should look like. And before we move further, something that I want to bring up is like okay, so these fields are in the data set. What if we want to let us say eliminate one of, like what if one of these columns are not useful? If we for instance remove this review text field from this schema and try to assign this schema to this data set, how many of you think that this operation will fail? Okay. And so, how many of you will think that it will work? Okay. So, there is a lot of undecided. Well, yeah, on the plus side, yeah, it will work. So that is one of the things, one of the advantages of being able to define your schema. There are two situations I could see myself doing it. One is like inferring the schema completely gives, as a developer, I would give the complete control to Spark to decide how to handle the data. Like, so at the end of the day, all these systems work on top of algorithms. So Spark inferring the schema has its own algorithms to infer the data. So for instance, when you are reading JSON, what happens is it reads the first line to infer what the schema is like. So given that if you already know that your data set has a lot of missing values, and the first line, if the first line is very likely to have a lot of missing values, inferring the, like letting Spark infer the data schema is going to go very bad. And on the other hand, the point that I just brought up, if you know that if you have a data set with 50 columns, and if you know that you only need 10, you can just explicitly define, okay, this is the schema that I want it to be. And the other thing is, if you know that a particular Spark might think that a particular number is an integer, but if you with your prior knowledge already know that that number should be able to accept long data type, for instance, this is a very important use case where you will definitely need to define the schema. So here I will put back the, I will run this and show you that, without the review text, it worked and it got executed successfully. And I will add it here anyway, because I need that field for the rest of the exercise. So when I add it, yes, I get the review text back. And so Maria was going through mapper, then the map partition function, filtering data, group by key, reduce by key. So all these functions have a counterpart function in SparkSQL and data frames. So because we are focusing on data frames right now, I will briefly go through some examples where you can use the Dataframe API to do similar operations, such as running a mapper, filtering data, and etc. So the first example I am taking is so selecting columns, where similar to SQL, there is a select function in data frames that allows you to work with column data, manipulate columns. So here what I have done is, I have from the data frame that I loaded that has a lot of different fields, I am loading a selected set of columns, and in this column what I am doing is, I am using two columns to run a mathematical operation and manipulate these columns and put them into one column. And finally, I am renaming. So what happens with Spark is, it works on transformations. So once it runs the transformation until this point, the output, what the output will have is a column that has helpful 0 divided by helpful 1, which is a horrible column name to deal with. So here what I am doing is, I am using a function to rename that column into a more usable, more easy to use name, column name. And another very big problem with big data is, you come across a lot of missing values. And those who have worked with our data frames, pandas data frames, you guys know, like there are functions in, especially in pandas, to deal with these missing values, to make them usable in our analysis. So similarly, the Dataframe API, it provides two main functions. One is the drop NA function, which is which allows you to drop records with missing values, and the fill NA function, which lets you replace missing values with default values, for instance. So, in this example what I am doing is I have this table right now which has a lot of null values, and so the overall also gets null values, in the sense missing values, mainly when you have divide by 0 errors, for instance, you end up with null values in the overall column. So, I need to correct these, like make this to come to a position where I can use this data. So, here what I am doing is I am dropping all the records that have missing values in the overall section, and then I am in the helpful column. What I am doing is all the missing values I am replacing them with 0.0, and once I do that, so all these null values I get here, they get replaced by 0.0, and now I can like it's a more useful way, more useful form of data for me. And now I am moving to the filter function, which is also available in the RDD API, which is used to manipulate rows. Now we use select to manipulate columns, and now we need to drop drop rows based on a expression, a condition. So, here what I am doing is I have this overall column which has a score from 0 to 5. So, I am filtering all the records, all the reviews that has an overall score greater than or equal to 3 here. So, when I do that, all these 2s, 1s, they get discarded out, and now I am moving into the group by function. So, it is very similar to the thing about the Dataframe API is you can, like SparkSQL and Dataframe APIs, they behave very similarly. So, when you group something, you need to, in Spark you need an action to trigger a transformation. So, when you are grouping data based on something, you need to run an action that summarizes the group of records together to trigger this transformation. So, for example, you can use functions such as count, sum, average, which will group by things based on a particular criteria, and then summarizes them into a sum value or an average value or a count. So, here what I am doing in the next example is now I am taking that filtered data frame, and then I am grouping it by the overall score, and then I am counting, okay, how many reviews have 3, the overall score of 3, how many of them have an overall score of 4, and so on and so forth. So, here you can see it is like a histogram of different scores, and then Maria was again talking about joining different data together, as she was mentioning, like when we work with big data, when we are in data science, one of the most important things, more useful things to do is to fuse different data sources together and make sense of the different views of this data. And so, joining is very straightforward in data frames. So, if we were to do this in terms of if we were to do a join in an RDD, first you need to load the 2 data sets, then convert it into the key value paradigm, and then run the join, and after you run, once you run the join, then you have a key and 2 values joined together, then you have to transform that data again to another another form that is more usable for the next set of transformations that we are going to run on that joint data set. So, this is where data frames make simple tasks easy, and so here, because we need another data set to join them together, I am loading the products data set, which has the ASIN again, and the title of the product, the price, and all the product related details, and then I am explicitly defining a schema for that for this data, and I am only selecting certain fields out of the available fields, excuse me. And so here I am reading this the product data set into a data frame, and what we have is yes, we have this data, and then here I am running the join where I have the filtered reviews data set on one side, and then I have the product data frame that I loaded just now on the other side, and I am joining them using the asyn column. And when I do that, I am at the same time I am using the drop NA function to drop any join record that doesn't have a title. So when I do that, yeah, I end up with about 25,000 records. And yeah, so I pointed out about, like, if we did it in the RDDs, we have to do this transformation, do the join, and come back to where we can start the rest of our analysis. So once we run this, we can see that now the data from the reviews and the products have been fused together, and the asyn is yep, you can see that it's been connected by the asyn. And then yeah, finally you have to save your data. So Dataframe API, it gives this in the new, especially in 1.6, going from coming from 1.4, it has tried to unify and make these API interfaces more generic. So earlier there used to be like JSON file, Parquet file, like different functions to read and save from different data sources, but now they put all these different diverse data sources into two umbrella like generic functions, where you do a data frame dot write dot Parquet or JSON, and it's the same with the reads. So here, so we took two data sets that are in JSON, and then we fused them together, we did some analysis, and we have an output. And maybe the next system that ingests this data accepts things in Parquet. So this is another main advantage in working with Dataframe API. You have a generic way of looking at schematic data, and you can like openly think about how you can ingest data in and out of the system. So going from there, let's get back to the slides again. So now some of you might be thinking, okay, now he spent the last 15 minutes trying to tell us to do exactly the same thing that Maria did like 15 minutes ago. And so why do we need data frames at all? So the next few slides that rationalizes this, it's mainly based on these slides from Databricks. I'm going to probably summarize and bring the most important points out from those slides. So this is a benchmark that Databricks came up with like about a year ago. So what this shows is you have this RDD API in Python and Scala, and then there's the Spark Python data frame and the Scala data frame APIs, and they are performing extremely well compared to the RDD API. This is mainly because that advantage data frames have by knowing the schematic nature of the data. It can figure out what is the best way to serialize the data, what is the best way to compress data, what is the best way to pass this data around and do calculations. So this gives an advantage in planning the directed acyclic graph that Spark builds to do these data transformations. So when it's possible for you to do something in the data frame API, this is one reason why you should do it. So just by saying that, I can't just stop saying that, I need to explain myself. So, I will spend the next slide explaining how the Dataframe SparkSQL API works. So, here what happens is we have two different interfaces through which the user expresses the logic to the Spark engine. One is the Dataframe API and the other is the SparkSQL engine. So, once you express your what you need, the data you need, it builds an unresolved logical plan, which is pretty much so Spark builds a plan on, okay, this is how I should transform this data to come to get the output the user needs. And then I started by mentioning a thing called the Catalyst engine. So, Catalyst is a SQL engine that which is part of Spark, which analyzes this SQL and data frame logic and try to map it into the big data world. So, now we have three things here. We have the RDD space, and then we have data frame space, and then we have the SQL space. In SQL space, we have tables, we have functions that are stored that are registered as stored procedures, and then in the data frame space, we have data frames which have data and schema. And deep down, all these are RDDs on the physical layer, which is like data that has to be actually transformed into output. So, the catalog is the part of the Catalyst engine that maps these things together. Okay, there is an RDD that connects to this data that connects to this data frame, and it is registered in SQL as a particular table. So, what catalog does is it takes this unresolved logical plan and it explains, okay, this reference refers to this particular object, and now going through the catalog, what you get is a plan, a logical plan, which also has all these data references and these object references. Now, once you have a plan, what Spark then does is, okay, now I have a plan, where can I cut down computation, how can I make this as efficient as possible. So, how Spark does that is it runs different heuristics, different optimization steps, and comes back with a more efficient logical plan. Now, Spark has a way to execute the data transformation logically. Now, it has to actually do it. So, what it does is, okay, now I need to come up with the actual physical plans. How are my partitions going to be moved? What partitions should go to which slaves, so on and so forth. And based on that, it runs a bunch of cost models and figures out, okay, I have these different plans to execute this particular transformation, but based on my cost models, I see that this is one of them is the most efficient least cost approach, and then it finally comes up with the efficient physical plan which it executes, and that is how it ultimately gains that computation, gains that efficiency. So, moving from that, I will go back to the tutorial. So, now we worked with the data frames. Now, I am going to touch a bit on SQL, SparkSQL. So, yeah, we talked about the Catalyst query optimizer, and so the other thing is what we do in SQL is very similar. The capabilities of SparkSQL is very similar to what we can achieve in data frames. So, I am not going to spend time doing function by function analysis of how SparkSQL is executed, but I am going to take a few functions, put them together and give you a gist of how SparkSQL can be used to deal with the same scale of data, same type of data to express what you need in a more simple way. So, now we stored the data in Parquet in the former stage. Now, we are going to load that data into SQL context, and then before we work in SQL, we have to make those references from that data frame space to SparkSQL space. So, we do that by registering these different objects with our SQL context. So, in this example cell, what I am pretty much doing is I am loading the data, and then I have this review df data frame, which I am registering in my catalog as the reviews table. And I already have the product data frame from my earlier stages, and I am registering that as the products table. And so, here I am just reading the two different data frames, and yeah, it has 30,000 reviews on 2,469 products. So, now I am like, I know, like I have already registered my tables, my data frames in SQL space. Now, I can run SQL like queries. So, here what I am doing is I am selecting the ASIN, the overall score, the review text and price from the tables review and products, where I am joining these two tables together on the ASIN. So, what I am pretty much doing is I am taking reviews that are from products that are at least $50 or more in price. So, when I do that, the resultant table I get is like a bunch of reviews that were made on products that are more than $50 in price. And so, now most of like some of you, as I saw earlier, are familiar with Hive, for instance. And even in Hive or even in SQL, we have this notion of user defined functions, which is more or less referred as stored procedures in SQL terminology. So, SparkSQL allows you to do similar things as well. So, if you want to incorporate a function that is not already implemented in SparkSQL, you can implement it programmatically, and then just as we registered the tables, we can register these functions that will be available in our SQL space. So, here what I am doing is I am using the regex library, and I have this little function. What it does is it takes a review and then it removes all the weird characters, like it replaces them with empty characters, and then it just converts the string into lowercase. So, here I have the results table. I register the result table, which is the output data frame from this query. So, I register it in my SQL context, and then I register this function as two lowercase function in my SQL context, and then I can run a query where I can select things normally, and I am using this function under the alias of two lowercase on this review text column, and what you get back is so pretty much what you get is so now you can see that like all these apostrophes and inverted commas, all these things have been removed, and everything has been converted into lowercase. So, there are things that you have to be concerned about when you are doing this, because one thing that I want to bring forward when I am explaining the register function feature is that once when we do this, the benchmark that I showed you a couple of minutes back, those performance guarantees do not hold when you use something like a user defined function, because at that point what you are necessarily doing is you are taking control from Spark and you are going back to the RDD like Python environment to do these computations. So, you cannot expect to have similar performance when you incorporate particularly like user defined functions like this. And finally, in the tutorial what I want to say is like the main thing about Spark is that you can mix and match as your application demands you to do so. So, I have this toy example here where I am, what I am in a nutshell, what I am going to do is I am going to use the RDD API, Dataframe API and SparkSQL in the same piece of code to design a pipeline. So, here what I am doing is I have a machine learning classifier which is in Python, and I use broadcast variable function to make it available, make this object available to all my slaves as a variable. And then in the first line what I am doing is I am using the RDD API to clean the data, and then I am running the classifier on each of the records to classify every record into different classes. And then here what I am doing is I am taking this, so I will probably, yep, then I am taking this RDD and I am defining a schema for this resultant RDD, and I am converting this RDD into a data frame. And here what you can see is it takes the data, it takes the classifier, and these are different reviews from different products that have been classified by the machine learning classifier into different categories. And then what I am doing is I am taking this enriched view data frame, the classified DF data frame, and then I am registering that in my SQL space as a table, which will be referred to as enriched views, because now it has been enriched with these classifications. And now I am running a kind of a long query where I am going to select these categories, and so the overall what I am going to do is I am going to take all the products that are $50 or more expensive, and then join 3 tables to get the product category and the average overall score that all the products from this category that are more expensive than $50 have gotten on their reviews. So, once we run this query, okay. So, this is a good example where you can see that you do not have to stick to a particular paradigm. You can move from one to another depending on how efficient it is going to make your pipeline and how efficient it is going to make your work. And so, here okay, we have got the results. So, here what ultimately happened is like I have taken these reviews and averaged the rating, and I have the summary average for each of the different categories, the average rating. So, before we sum up today, I just want to bring in just brief you about some cool features that especially Dataframe's API has been like Spark is working a lot on the Dataframe API lately, and they have been adding some really nice features coming from mainly 1.4, 1.5 to 1.6. So, one of the main and very useful features that they have added is in, so I am going to mainly focus on Parquet data structures in this section. So, they have added schema evolution, where in Parquet you can start with a simple schema, and you can keep evolving your schema by adding new schemes, and Spark is now able to identify multiple schema that are compatible with each other and handle them all together in a single data frame. And one of the other cool features that I came across, that went a bit fast, came across the other day is now they have implemented this feature where you do not have to load Parquet files into data frames. You can directly query on the file, the data file, And this is mainly because Park A is a columnar data format, and it has it lets you to load the columns that are only important for querying and any operation you carry out. So this is one of the other new features that I find very interesting, where you don't even have to load the whole thing into a data frame, where you can just run the queries on the data source itself. And then the other thing that I want to bring out is like table partitioning. So there's this new feature called partition discovery in Spark 1.6. So table partitioning is something that people used to mainly store data related to categorical variables. So when you store, let's say, some user records, for instance, from different countries, mainly in systems like Hive, something people tend to do is like hold user profiles from the US in one file, in the UK in another file, something like that. So Spark can now identify this table partitioning, and it will automatically figure out, okay, these are in this particular in this directory path, these are categorical variables. So you know what, I am going to load all this data and add these different categorical variable as part of the schema. So if you can see from this example, here you have different directories for US and China, and this is for male and female genders. And when you load this data and load the schema, you can see that the gender and the country are already implicitly recognized by the Dataframe API. And finally, this is something that that Databricks has Spark has introduced very briefly in the in Spark 1.6. So the dataset API, which is they've given like a sneak peek preview kind of thing. So Spark is mainly, the inspiration behind Spark is to make complex analysis with minimal programming effort, and the whole inspiration behind dataset API is to make these applications run faster and more efficiently. So I've been constantly talking about the Catalyst engine, and another fascinating project they've been working on is the Tungsten project, which is taking data and making them closer to bare metal servers by trying to bypass the JVM layer. So they've been constantly introducing a few parts of Tungsten, evolving from Spark 1.4 to 1.6, which has made like like our shuffling jobs and memory management jobs a lot more easier. But yeah, in the coming versions they are going to focus more on like extending the Dataframe API to have type safe object oriented programming interfaces. And right now dataset API is mainly for Scala and Java development. And if you want more detailed information about the dataset API, you can go into this link. It's like a very nice blog post that explains the inspiration and some really fascinating, very interesting benchmarks. And yeah, moving from there, this is like like the links for the dataset and like some resources that you might find interesting to explore from here and expand on the subject. And if you have questions, you can always buzz us in Twitter. And finally, we are looking for a data scientist. If you are interested, if you are excited by machine learning, if you want to work with Apache Spark and like very large scale data and work in real world like real world problems, data problems, give us a buzz. We are looking for a data scientist. Yep, that's me. Thank you.